Hi, Year 12. Today's video is looking at vertical and horizontal asymptotes and aligns with exercise 2B in our Year 12 textbook. Okay, so you've had a little look at asymptotes in Year 11. We generally had a look at the asymptotes that were vertical. You may have come across a few horizontal asymptotes that we're basically going to be looking at a lot more complex functions or equations. And if your function or equation has a fraction in it, it's probably going to have an asymptote. And we want to have a look at how we can figure out how to find out where the vertical and horizontal asymptotes are. So what is an asymptote? Well, an asymptote is a line where the function gets really, really close to, but does not touch. That was our definition from Year 11. That's generally the definition for this year. However, there is a case where, and it kind of goes against this, where a line can cross an asymptote at a point. It doesn't fit the definition, and we might get to come across one of those examples today, and I'll show you if we get to see that later on. Okay, so a vertical asymptote. If we scroll over to the side over here, I've just got some diagrams of the two. The dotted lines are the asymptotes. So a vertical asymptote is a vertical line where our function, being the blue line, gets really close to but is not going to touch. Horizontal asymptotes would be kind of an imaginary line that's going horizontal, the blue line being our function, which again would get really close to but never touch. So where the asymptotes are basically going to tell us what our graph's going to look like, and they're really, really important in figuring out what our graph looks like. So we need to know how to find our vertical and our horizontal asymptote. So let's have a look at those two things now. Now we're going to start by looking at vertical asymptotes. Okay, the 2 dot points here, basically always factor the function as far as possible first, cancelling any like terms on the top and the bottom that are able to be cancelled out. If the denominator has a 0 at x equals a and the numerator is not 0 at x equals a, then the vertical line x equals a is an asymptote. For example, if we had the function y equals 1 over x minus 3, we know here we cannot divide by 0, so x minus 3 can't equal 0. So x equals 3 is one of our asymptotes. What this second point also is saying, if we had an x minus 3 on the top line and an x minus 3 on the bottom line, yes, we can't divide by 0, but our top line and our bottom line are the same. So what we'd have there would be a cancellation. So we're not having an asymptote in that case. So just be aware of that. So once our vertical asymptote has been identified, so in this case it would be x equals 3, the behaviour of the curve near that point x equals 3, we're going to have a look at by using the table of signs from our last exercise. So we pop our x and y values in and figure out what's happening near that point on both towards that point from the negative side and back towards the point from the positive side. And that's going to help us describe and graph what the graph's going to look like. Okay. Also, we're going to have a look at horizontal asymptotes. Now, these ones we haven't looked at much before. In order to find a horizontal asymptote, what we need to do is divide the top and the bottom by the highest power of x. And we will have a look at that, and it'll make a little bit more sense when we do an example. And then we use this fact that 1 over x goes to 0 as x goes to infinity. So we haven't looked at that a lot yet. So as x goes to infinity, it means x gets really big. So let's say, for example, 1,000,000. In my calculator, if I popped in 1 over 1,000,000, my number is going to be so small, 0.000001. It's near 0. So basically, the bigger my number gets on the bottom, the closer that 1 over x gets to 0. That's what that's saying. If my x goes to minus infinity, so it goes the other direction on our number line, then the number on the bottom, for example, if we again picked, say, minus 10,000 or minus 1,000,000, 1 over that is going to go towards minus 0.000001. So it's getting small. They're both going to 0. Okay. Sorry, not both going to 0. 1 over x is going to 0 as x goes to infinity as x goes to minus infinity. So if a function tends to a definite limit b, so if our function tends to go to a number as x goes to infinity or as x goes to minus infinity, then that line, y equals b, or y equals whatever our number is that it tends to, is the horizontal asymptote on the right or the left. So we'll have a look at that right now in an example. So if we scroll down, here is our first example. And we're going to be examining the behavior of the function y equals x plus 2 over x minus 3 as x goes to infinity and as x goes to minus infinity, noting any horizontal asymptotes. Okay, so if we're looking at part A, we're looking at our horizontal asymptotes. So if you look back to what the note said, what we needed to do for our horizontal asymptotes, just going up above. So I'll just fix my screen up here. What it said we needed to do was, oops, there we are, divide the top and bottom by the highest power of x in the denominator. Okay, so let's go back down here. What does that do? That means the denominator is down here. The part of our fraction on the bottom is the denominator. The highest power of x is just x. So we're going to divide everything by x. So I'm going to start off with x plus 2 over x minus 3. It's just going to be a little bit of algebra. We're going to divide the top line by x. I'm going to divide the bottom line by x. And I'm going to split my top line up into x over x plus 2 over x. And now my bottom line is split up the same, become x over x minus 3 over x. And go one step further, and what that will become is 1 plus 2 over x on my top line, and on my bottom line I get 1 minus 3 over x. So we've just basically manipulated our function to look like this, and what we can do is we can have a look at what's happening as x goes to infinity and x goes to minus infinity, and see if we can find out what our asymptote might be, or if there is one. So what I need to do now is check x going to infinity. So as x goes to infinity, over here, what's happening is x here on the bottom gets really, really, really big. So this whole number here gets really, really small. Okay, and tends to 0. So we're going to have a 1 on the top line. As x goes to infinity here, on the bottom, my 3 over this very, very large number gets really, really small. So this also goes to 0. So I'm ending up with a 1 over a 1, which is 1. So as x goes to infinity, y goes to 1. Let's also have a look at what happens as x goes to minus infinity. It's going to be the same thing anyway. But as x goes to minus infinity, this number on the bottom here gets really, really, really small, something like, minus 10 million. This whole thing here becomes very, very small, near 0. So we have a 1 on the top line, and the same happens to the bottom. This goes really, really small. We end up with a 1. So we're going to find that in this case, y equals 1 is a horizontal asymptote. Okay, that's part A. Part B says find any vertical asymptotes of the function, and then we're going to use the table of signs to describe the behavior near that. Okay, so what we want to do now is just look at the vertical asymptotes. So that were the ones that we were doing last year. We're going to have a look at the bottom line. We know x minus 3 cannot equal 0. So x cannot equal 3. That is an asymptote. But when we were looking last lesson at our table of signs, we also wanted to have a look at the zeros in that table of signs as well. So we also need to know where it cuts the x-axis, and it cuts the x-axis at y equal to 0. So that's going to find our 0. So if you can't see that straight up, it's going to be minus 2, but let's pop it in there and have a look. So if y is equal to 0, we've got x plus 2 over x minus 3. If I multiply both sides by x minus 3, I get 0 equals x plus 2. So I get x is equal to minus 2. That is where it cuts the x-axis. So looking at our table of signs, what we want to do is we want to have our x and our y and our sign. And we want to look at it at minus 2 on either side of that. And we also want to have a look at it at 3, which is the asymptote. So let's go to the left of minus 2. Let's go minus 1. Oops, not minus 1, minus 3, sorry. In between minus 2 and 3, well, probably an easy one would be 1 or 0. I'm going to do a 0. And then let's do a 4 as well. Let's get those values. So if you want to pause that, check what your values are. before we put those in, what we remember is x equals 3 was an asymptote. So in that case, we don't have a sign for that one. X equals minus 2 is where it cuts the y-axis. So that was at y equals 0. So we don't really have a sign for that one either. What we get for minus 3, we'd end up with 1/6, which is positive. 0, we're going to end up with minus 2/3 as our value for y, or our function, which is negative. And for 4, we would end up with 6, which is also positive. So we've got all our information there. Let's see if we can actually sketch it. If you've got room there, I'm going to do one over to the side over here. Let's see what we know. Let's have a look. So the first thing we looked at was we found our horizontal asymptote is at y equal to 1. So we've got a horizontal asymptote in here at 1. We have a vertical asymptote we found here at x equals 3. So I'll pop that one in as well. Let's fix my page up. Okay. So x equals 3 back here. I might just change the colour for our graph. And we said there was a 0 at x is equal to minus 2. So it cut the y-axis at x is equal to minus 2. Sorry, I'm just fixing my page up again. Okay, so let's pop that one in as well. I said minus 2, wasn't it? Yep. Okay, so x is equal to minus 2, so that's down here. Okay, well, you might be able to figure out what's happening here. We're actually going to have a hyperbola, and generally when you've got x's divided by x's, it's going to be a hyperbola. But let's see what's happening, what our graph is telling us, or what our sign is telling us down here in our table of signs. So, we're looking at minus 3 to start with, which is to the left of minus 2, and we had a positive part here. So, over here, we're somewhere up here, we're positive. To the other side of minus 2, I picked 0, we were negative. So down here, we're negative. 3 is our asymptote, so we're going to be going around here, like this somehow. To the right of 3, we're going to be positive. We're going to be going around here and around here. The other thing we haven't looked at is where it cuts the y-axis. Cuts the y-axis when x equals 0. So if we were to pop a 0 in here and a 0 in here, we'd get minus 2/3. So it's actually going to cut, I'll zoom in a little bit there, in here at minus 2/3. And our graph is going to look something like this. It's going to go through there and go there, like that. And that's our function. Okay, scrolling down a little bit, the next example wants us to examine the behaviours of these functions as x goes to infinity and as x goes to minus infinity, noting any horizontal asymptotes. So remembering what we did for horizontal asymptotes, they were the ones that were a little bit harder. We had to divide through, I might just go back and show you again. We had to divide through by the highest power of x in the denominator. So let's look at A first. Well, the highest power of x in our denominator here is x squared. So we want to divide everything by x squared. So we can have x plus 1 over x squared. We divide the whole top line by x squared, the whole bottom line by x squared, and we're going to split that x squared up into each term. You could probably do this in your first step if you like. So I'd have x over x squared, which becomes 1 over x, plus 1 over x squared. There's my top line. Put the x squared into each one of those top parts. The bottom line, I have x squared over x squared becomes 1 minus 4 over x squared. We want to have a look at what happens as x goes to infinity now. So as x goes to infinity, 1 over x becomes very, very small, or 1 over a very, very, very large number. If you want to pop that in your calculator to remind you, 1 divided by 1,000,000 is very close to 0, so we'd end up with a 0 on the top line. This one here also, as x goes to infinity, would become very close to 0. we're basically taking a limit on each of these. We're looking at the limit as x goes to infinity. At the bottom line, we'd have a 1 minus a 0. So we're basically having y go to 0. The same would happen as if we were going x going to negative infinity. This would become, again, very, very small and close to 0, very, very small and close to 0, and we'd end up having y going to 0 in that case as well. Okay, so that tells us what our asymptote is. Y equals 0 is an asymptote. Horizontal one though. We could go through and find lots more information. We could find our vertical asymptotes. We could find where it zeros, and we could look at the sign near those points and graph that as well. And that's what you guys are going to be having a go at. Let's look at B. Again, in this case, we're only wanting to look at the horizontal asymptote. So we're dividing through by the highest power x in the denominator, which is x squared. So we'll end up with 2 over x squared over x squared plus 1 over x squared. So we'll end up with 2 over x squared on the top, and the bottom will end up with 1 plus 1 over x squared. If we're looking at what happens as x goes to infinity and x goes to minus infinity, it's basically going to be the same for each of these. And the more you do these, the better you'll get at them. So as x goes to infinity, on our top line, this number here gets really, really big. So 2 over a really, really big number gets really, 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 really tiny, and it's looking at going to 0. So we're going to end up with a 0 over a 1 plus 1 over x squared. X squared is going to infinity, so that gets really, really small. So it's basically 0 over 1, which is 0. So y is going to 0. As x goes to minus infinity, exactly the same thing is going to happen. So y equals 0 is a horizontal asymptote. And I'll have a look at C, and then we might actually have a go at drawing a tricky graph as well. Okay. Over here, let's have a look at the horizontal asymptotes. Again, we're dividing through by the highest power of the denominator, which is x squared. So we're going to do that for the top and the bottom. I'm going to go straight off and write it as x squared over x squared on the top, plus 5x over x squared, plus 6 over x squared. That's our top line. Our bottom line becomes x squared over x squared, minus 4x over x squared, plus 3 over x squared. This is where your algebra comes in really handy. We'll end up with 1 plus 5 over x plus 6 over x squared all over 1 minus 4 over x plus 3 over x squared. So to figure out whether we've got horizontal asymptotes, we're going to have a look at what happens when x goes to infinity. It'll be the same as when x goes to minus infinity. And as you can probably see, getting quite good at them now. Our top line, when we have an x on the bottom, when x goes to infinity, this whole thing gets really small and it goes to 0. Again, pop a number in your calculator, 5 over a million, and see what happens. It becomes very, 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 very tiny. So our top line will become 1. Our bottom line will become 1. 1 over 1 is 1. So as x goes to infinity, y tends to 1. So y equals 1 is an asymptote. Oh, is a horizontal asymptote. Okay, now I'm going to have a look at another question. This one is not in your booklets. I want to do this one, however. You will find this in the OneNote. On the side, we're looking for our timeline. We've got extra pages in there. So 2B, vertical asymptotes, horizontal asymptotes. You'll find that in there. Now, this one is an odd-looking graph, and I haven't shown you guys this before, so I think it's a really good one to have a look at. The function we're looking at is 1 over 4 minus x squared. It's good to have a go at. The more you do ones like this, the more familiar you'll be with the odd shapes that they are, or the strange shapes that they are, I should say. And it stepped us through this one. Okay, we're going to test whether this function is even or odd. Now, you don't always need to do this, but it helps you really, if you've got the shape of half of the graph, if you know that it's even, then it's going to be reflected around the y-axis. So that's so much easier to work out, and you don't need as much time. If you know that it's odd, you're basically flipping it and reflecting it through the origin around the x-axis. So thinking about what our tests were for even or odd, what were they? So if f of x equaled f of minus x, it was even. And if f of minus f of x equals f of minus x, it was odd. So the easiest way to do this is to just figure out what f of minus x is and see if it equals one of these, and it's straight up even or odd. So let's do that. Okay, so f of x is 1 over 4 minus x squared. F of minus x is going to be 1 over 4 minus, wherever there's an x, we're going to put a minus x. So let's see what we've got. We've got 4 minus x squared, or anything minus squared is just itself without the minus, so it's going to be 4 minus x squared like that. So what we end up with is the function itself. So it's an even. So we know that what we draw is going to be reflected about the y-axis. It's sort of like, think back to last year, y equals x squared was an even graph, and it was reflected about the y-axis. That might help us. I don't know yet. Hopefully it does for part E when we draw it. Okay, part B says find any vertical asymptotes of the function. Okay, remember the vertical ones were the ones we looked at last year that were a lot easier. They were the ones that are looking at what happens on the bottom. Okay, giving us that the bottom line, 4 minus x squared, can't equal 0. So let's factorize this out. Difference of two squares. 2 squared is 4. X squared is also a square there, so we're going to have 2 minus x. 2 plus x cannot equal 0. So x cannot equal 2. X cannot equal minus 2. So there are asymptotes. X equals plus or minus 2 are our vertical asymptotes. So that was a nice easy one to work out. Part C says to construct a table of signs and describe that behaviour of the curve near it. So we've been doing those for a little bit now. So the table of signs, x, y, and our sign. We're popping in any information that we already have. And what we know is we have asymptotes at minus 2 and plus 2. So minus 2 and plus 2. And we need to pop in some values around that. So we want our value to the left of minus 2, which would be, I'll pick minus 3, nice and close. In between minus 2 and 2, I'm going to pop 0 in because I like that one's nice and easy. And we might pick 3 as well. Okay, so let's pop our values in. Now, we know our asymptotes here. I'm not going to have any values in there. You can put a star or an N in there. So there's no sign. Okay, there are asymptotes. Now, we need to find our y values by substituting in our minus 3 into our function here. Actually, better pop it up into here. Into where x is, popping in 0, popping in 3, and seeing what our function is. Remember, function is just our y value. Okay, so if we do that, we're going to end up with minus a fifth in here, which is a negative. We pop 0 in, we're going to get minus a quarter. Oh, not minus a quarter, sorry, positive a quarter, which is a positive. And if we pop 3 in, we're going to get minus a fifth, which is a negative. Now, interesting that you will note that when we popped 3 in and minus 3 in, we've got the same y value. You think of why that might be? That's because our function was even, okay? So it flicks up and repeats an exact copy over the y-axis, so they're going to have the same values. Okay, part D says, name the horizontal asymptote and describe the behaviour of y for large x. So basically, as x goes to infinity. So we just did lots of work on the horizontal asymptotes. So I might just write that function down again. Our function is 1 over 4 minus x squared, or y equals 4 minus x squared. To find our horizontal asymptotes, we had to divide through by the largest denominator, largest power of x on our denominator. So we'll end up with 1 over x squared as our top line over 4 minus x squared all over x squared for our bottom line, which will become 1 over x squared on the top line. And then our bottom line, we break this part up into each of those. 4 minus x squared minus 1. We're going to have a look at what happens as x goes to infinity. So as x goes to infinity, this top line becomes really, 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 really big. sorry, really, 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 really small, because this one becomes big and it goes to 0. Our bottom line, the x squared becomes big, so our 4 over x squared becomes 0, close to 0, and we're taking away a 1. So we're basically having a 0 over a minus 1, which is 0. So as x goes to infinity, y goes to 0. So y equals 0 is an asymptote. Okay, let's see if we can put all that information together and draw our function. So, let's see if we can pop that over here. Just put in what we know and then see if we can have a look at our table of values, if that's telling us anything. We might need to pick a couple of other points if need be, and that's okay. Okay, so I might just change colours. Let's go green. So we know we have got vertical asymptotes at -2 and at +2. So we know that. And we said we have a horizontal asymptote at y equals 0. So don't forget that one. So that's an asymptote in there as well. So there's a lot of sections to this graph. We know that it's even. So whatever happens on this side is going to be mirrored over on this side. It's going to reflect about our y-axis. Does anything cut our y-axis? That happened when x equals 0. Yes, we found that over here. So we've got our, I might change the graph to another colour. So it's going to cut our axis here at 1/4. We know that. Let's see if we know anything else. Let's have a look down here. We know that when we were to the left of -2, we were negative. So we're down here somewhere. We were at -1/5. So at -3, we're at -1/5. So down here, we're pretty close here. So we're moving along this way in our graph. We can check what happens as we get really close to -2. So you might want to try -2.1. If you were to put -2.1 in there in your function, what you would have would be a number a little bit bigger than 4. So -2.1 squared, a little bit bigger. 1 divided by a number that is, what have we got? It's going to give us going to -infinity. So we're going to be having that graph going down there like that. So what we're probably going to find is that because it's mirrored around the y-axis, we're going to have our graph on this side looking like that as well. But let's double check. Let's see what's happening on this side as well. So we've got +2 here. That's our asymptote. To the right-hand side of that at 3, we're about at -1/5. So we're down here. So it's going to do the same thing. I'm going to move around here like this. My graph's not beautiful, but that's enough to sort of give us enough information. The other thing we don't know about is what's happening in here. We know it cuts here at -1/4, and we need to figure out what's happening. It is most likely going to go up like this, but let's have a look. Let's try a number to the, sort of in here basically. We haven't looked at what's happening in this part of our table of signs. I think we need to do that. And having a look at what's happening as we get really close to 2 here. Are we going down here? Are we going down here? So let's do that. So let's look at a number, for example, 1.9, for example. If we popped 1.9 into our function, we'd get 4 minus 1.9 squared, which would be a number that would be very, very close to our 4. But it wouldn't quite be close, wouldn't quite be 4, so we'd have 1 divided by a really, really tiny number, which would mean here we'd be really, really large. I could try a number down here, but it's going to mirror it. We were really close to -2. If we popped in, say, -1.9 in here, we'd get a really big number as well. So that's what our graph is going to look like. That was a trickier one. But going through the same steps we've done before, I think we've got enough info to make it work.